Okay, so in my last video, hopefully you saw our 1920s magic trick, our wine glass on a string being suspended by a paper clip. Now in that we talked about how friction between the string and the pencil is what holds it up there. But how does the string get wrapped around quickly enough? Well, the answer to that lies in angular momentum, which, unless you're an A-level student in the last couple of months, you probably won't have come across yet. So like all good physics, the first thing we'll do is draw a diagram. And here we have just some axes, that's our pencil there. And we have our paper clip on its string, starts off at some distance, r from the start. And then as we drop it, it goes down, rounded up, and then round about 4 times until it stops. Okay, and we notice this, that r is getting smaller, and that becomes quite important. So hopefully you've heard of momentum. So momentum is equal to mass times velocity, and it basically is a measure of how hard it is to stop something. So the more momentum something has, the more difficult it is to stop. A light thing moving slowly is very easy to stop. A heavy thing moving very fast is obviously an entirely different situation. So analogous to that, we have angular momentum, which is L times the moment of inertia times the angular velocity. So the angular velocity is fairly self-explanatory. It's the velocity as it goes round, so it's the rate of change of angle rather than rate of change of distance. It's measured in degrees over time, so that's angular momentum. The moment of inertia is more complicated and gets horrendously complicated when you get to undergraduate level and beyond. And this depends on 2 things. So it's the mass and the distance from the centre of rotation. And so in this case, we have a distance from the centre of rotation that is changing, and that r is getting smaller. And because angular momentum, like linear momentum, is conserved, as r goes down, because m remains the same, I gets smaller, which means omega has to get larger in order to keep L, our angular momentum, the same all the way through. So in practical terms, what that means is as it drops down and the string is shortened by the wine glass dropping downwards, the radius is reduced, the angular momentum increases more rapidly, and that's how it's able to travel very quickly round and round and wrap the pencil before the wine glass hits the floor.